100 years ago, astronomers believed that our Milky Way galaxy was all that there was in the universe. Observations from that time revealed its shape and size to be static and unchanging. The idea of a static universe didn't seem right to one physicist. Albert Einstein reasoned that since gravity worked to bring matter together, everything should be moving closer and closer until finally the universe would collapse in on itself. But since no such movement was observed, Einstein theorized that there must be another force that worked to repel objects from each other, counteracting gravity and maintaining a static universe. He called this repulsive force the cosmological constant.
Einstein introduced the cosmological constant as a fudge factor. He thought he knew the answer at the back of the book. He thought that the universe was static, and so he put in this fudge factor. And this is kind of one of the neat things about theoretical physics, where we're trying to, invent new ideas, is that, you grasp at straws, and you sometimes invent an idea and it turns out not to work. But in theoretical physics, you can never put the genie back in the bottle.
When new discoveries seemed to contradict the existence of his anti-gravity force, Einstein called the cosmological constant the greatest blunder of his career. The new wave of discoveries began in 1917. By 1929, most astronomers were convinced that the universe was larger than they had thought, and it wasn't static. It was getting larger all the time.
That led to this idea of a Big Bang universe. That is, if galaxies have been expanding, and we see them expanding now, then they must have been closer together in the past. And there must have been a time when the universe would have been very dense, would have also been very hot. And along with the general theory of relativity developed by Albert Einstein, this led to this picture of the Big Bang universe.
The Big Bang generated so much momentum that it's driven the expansion of the universe for 15 billion years. Scientists have predicted that the force of gravity should be slowing the expansion down. To their surprise, recent observations have produced data showing that the rate of expansion is actually accelerating.
If our discovery is correct, it suggests that the universe is beginning to accelerate in its expansion, to go faster and faster.
Our understanding of gravity's impact on galaxies and stars may be incomplete. It appears that gravity's pull is not strong enough to slow down the expansion of the universe. Perhaps some other force is countering gravity, pushing all the galaxies apart. The thought of such a form of energy is strange, but it's not new. It sounds a lot like Einstein's idea, the cosmological constant, which he so famously called his greatest blunder. Now it appears that the idea of a force countering gravity is winning over contemporary astronomers.
If Einstein heard these results today, he would say, Yahoo! It would be such a thrill for him, I think, to see that his original prediction that such a weird stuff might exist in the universe turned out to actually be true.